Okay, so we're going to kind of jump right into it this week. So what I'm going to do is I'm going to show you a little bit, and then actually I'm going to show you some that's kind of not part of the lab. And then what we'll do is actually, if we have time at the end, what I'll do is, so if there's someone here that wants to volunteer, if you want to share your screen, we can go through like the first, a couple examples from the lab with someone else driving. Or if someone wants to tell me what to type, I'm more than happy to do that too. But moral of the story is, if there's time, what I'd like to do is get a student to actually drive the conversation or drive the speed that we're going. So anyways, one thing real quick, just to kind of get it out of the way. So we are in lab 5 now, and I love lab 5 because we actually are going to abandon everything we did in labs 2, 3, and 4. So our underscore lab tables are no more. So just keep that in mind. We are not going to put underscore lab on anything anymore. You're going to actually be querying the right tables. And also, the other thing that I want to make you all aware of is that in lab 5, what I want you to do is actually, we're going to start from scratch here. So what we want to do is actually have our calls right here. So you'll notice that I have like cleanup, create, and seed in here. We want these in there. And mine are a little bit older, so don't worry so much about it. But yours will be a little different. But we want those in there because we don't really care to run labs 2 through 4 anymore. So let's just skip all that and let's just clean everything up, create it, seed it in lab 5. And the other nice thing about that is it just goes faster, really. And I need to fix mine, so let's hurry and do that real quick here. So let's go to home, data, 225, Oracle. Yep, Oracle. And I have the old ones in here, but we actually, I should probably call the new ones here so we have the same data. So the 3 scripts I need to run is Oracle lib1 utility. And yours is probably already set up this way, but I'm using some older ones. So create, and create should be create Oracle store 2.SQL. And then finally we have the last 2, which is precede. Precede Oracle store, and then the last one is our seed. And it is called seeding.SQL. So I'm going to hurry and save that, and we're going to hurry and run that real quick just so we know. Alrighty, so it looks like we get a bunch of really good stuff. So I'm just going to really do some quick checks here. Select everything from contact, make sure. Oh, and I guess I should probably write. Sometimes when I say it, I forget to type it, which is really funny. Okay, so it looks like we got those, and let's select everything from line to line. All right, so it looks like we're good. So I have all my stuff here that I'm going to be using for lab 5 now. So I'm going to close out of this one because I don't have to worry about it too much on the terminal today. So now that I'm all created, I'm going to be mostly working inside of SQL Developer. And the reason why is so that I can give you guys immediate feedback without having to save files, spend a lot of time doing that. You're welcome to use SQL Developer too if you want. It is nice because you can just run queries real quick. So now, like I said, I don't want to focus on the lab too much off the bat. So what I kind of want to show you is just more a little bit of just joins in general, right? And to do that, I'm going to bring up a diagram real quick. It's my favorite one. And I should probably do it over here. I don't want to. There's a really good resource. And if you Google SQL joins on like a Google image search or DuckDuckGo image search or whatever, this is basically what you're looking for. You can just do a search for SQL joins. This is, if you can visualize joins in this way, it is going to make life a whole lot easier. So I'm actually going to keep this open because we are going to refer to it as we do this. Because the first thing we're going to do is talk the difference between the two different versions. Because I noticed someone in Slack asked, how can we do it this way and this way another time? So we're going to talk a little bit about that right now. So I'm going to show you the old way first. And I'm going to show you the old way first, so that way when you see the new way, we can talk about why it's better, why they switched to it. So the old way is called the ANSI89 syntax, and you'll see that kind of on websites and stuff. But they didn't have as many features in ANSI89 as they did in ANSI92. So we're going to do a join with the old way, and then we're going to do a join with the new way. And really what we're going to be talking about is, let's do an example with inner joins, right? So these are our inner join examples. Now, before we get kicked off, let's look at this, because what is an inner join? Well, if we look at this and visualize it in these Venn diagrams, an inner join is when we have the middle. So when you look at these, imagine that each circle is a table. So we have table A and table B. An inner join is going to combine. When you think of a join, picture we're going to glue records together side by side. So we're taking one table and another table, and we're going to glue them together horizontally, right? Not vertically, horizontally. We'll talk about the vertical in a minute. But the join, what makes a join so special is because we are going to match data as we do it. So like you've seen in our labs, we have a contact table and we have a telephone table. Well, how do we get the data to come out properly? Well, we have to use a join because the data is in two separate tables, which is a good thing. But how do we get the data to match up and come out the way we want to? And that's what we're going to do here. So when you picture this, imagine A being contact and B being telephone. So when we do an inner join, what we want is the stuff that have matches. Okay, that's what that the middle is. What do A and B have in common? And so in our case, if we look at address and telephone, we're looking for records in address that have a telephone number attached to their contact ID. So real quick, let's just do a select everything from contact. And you'll notice we have a bunch here. The important one being our primary key, which is the contact ID, and then we're going to select everything from telephone. So basically what we're going to be doing is we're going to be looking for records that have contact IDs that exist in both, because that's what we're going to specify. So let's do that real quick. And this gives you an example, so you can kind of say, select our select list from, and it shows you how. But we're going to show you the old way first. So we don't have an inner join in ANSI89, which is really important because for some reason Oracle decides to test on that. So I'm going to just select everything for right now. And we're going to select that from contact. And then because we don't have an inner join, I'm just going to say join. And we're going to join that with telephone. Now, because we don't have certain syntax, we have to do it manually, like I said. So we're going to say select everything from contact, join telephone, where, and actually the way this works like this is goes something like this. So we're going to select from contact, comma, telephone, where contact ID is equal to telephone ID. Now, like I said, I'm going to show you the longhand here real quick. So let's run this, and boom, there we get what we want. Now let's go look and make sure we have our telephone stuff. Yep, there's our telephone numbers, and then we want to make sure. And what we did here is we specified where we wanted to join on, and this is our primary key and our foreign key combination. So now you can kind of see like, oh, that's why we did that. We made that constraint, right? We made that constraint to say, look, a telephone has a constraint and it's a foreign key on contact.contact ID because we were going to do stuff like this. So when we look at this, we can say, okay, contact ID 1001, and we can come over here to the contact ID, and we have 1001 there. So we know it's matching, which, you know, we told it to match, so we don't usually check for that, but that's just to show you how it's doing it, because we're basically contact table goes all the way over to here, right? So contact is this way, and everything else is telephone. And you can kind of see how we glued those records, those two tables, and I guess we should really say records. We glued those records next to each other, because now all of a sudden we can go, I want contact dot first name. Let's make this a little prettier. So we want contact dot first name and we want contact dot last name, but we also want telephone dot telephone number. Okay, because now that we've joined those two records together, we have access to all of those columns, right? Now, an important thing to remember when you're doing select statements is, even though we only see what we select, right? Because I only did these three columns, through the rest of our query, we actually have access to all of the other columns. So I can come in here and say order by telephone dot area code. Okay. Basically, I'm going to sort this by area code. Well, area code isn't even here, but we can still use it because in the background, all that data is still there. So just keep that in mind, that even though you're only selecting these, you still have access to all those columns behind the scenes. Once they're in the from clause, you have access to them. Okay, so let's this was a very longhand example, so I'm going to take off the order by just so we can keep it slimmed down. So this is the longhand example. Now I'm going to do the same thing this time using table aliases, because you'll notice that I typed out contact all the way, which is fine if you choose to do that. I know a lot of people do. I personally don't like to. So what I'm going to do is I'm actually going to do this same query just with table aliases. So instead of typing out contact a bunch of times, I'm going to give it a shortcut, and I'm going to call it C. So I'm going to select C.firstname, C.lastname, and T.telephone number. Now here's where I have to make this work. So now when I say in my from clause, I say contact C, so a space and then the alias. I could go as well, that works too, but I usually just do a space and then whatever I want it to be. It doesn't have to be one letter. You could call this contact, you could call it whatever you wanted, you know, CON or whatever. But we're going to call it C for right now, and then we're going to do the same thing for telephone. And by specifying the comma, we're basically saying select from both. But we need to tell it where, right? Because, for example, while we're here, let's do this. Let's try it without saying where. If I do this, what we do is we get every possible combination because I didn't specify where. So you look here, and basically what we have is this full join. Okay, we're getting everything, and it's really contact times telephone, because If I order this by, let's do 1, 2. You'll notice that Brian Smith actually has a record for every telephone number in our database. Okay. So we multiplied. We got every possible combination because every contact will have every telephone number. So a lot of rows, which we don't want. So I guess to show you how this ANSI89 works on the back end, because I really want you to understand when we get to ANSI92 why this was such a big deal. So in ANSI89, when you do the join, it multiplies all the rows together. So in this case, we have, let's do this. Let's do select count from contact, and then let's see how many's in there. We have 12. Let's see how many telephone numbers we have. So we have 12 contacts and 12 telephones, right? So, you know, basically what goes from, and we're actually getting more, I think you have this only, so we end up with 144 rows total. And so basically what's happening is the computer is doing a lot of work on the back end because it matches every row. And then we use our where clause to then eliminate rows, because we only want the rows where the contact ID is equal to the contact ID in both of them, right? And in fact, let's do this just as an object lesson, right? Let's pull our contact IDs and we can see what's going on here. So if we run this now, you'll notice that contact ID 2012 has a bunch that don't match. So when we specify our where clause, it's going to eliminate everything where these two numbers don't match. So it's going to eliminate all those and only show this one record, which is the one that matches, right? Now, that may not seem like too crazy, except for the fact that when you become like Facebook or similar, you know, you have millions of rows. And so, or more, you know, you're talking billions of rows. And so what you don't want to do is have to make the computer work through a billion rows every time you want to output someone's telephone number, right? And so that's how that one worked, is you get everything and then filter out. Well, ANSI92, they said, well, this isn't very efficient. There's got to be a better way. And so on the back end, they worked their C magic, their programming magic. And what they did is they got the solution to filter as they match. So we can do the same thing here. So this one's a little different because now we have this. Now, in this one, we say inner join, and it knows automatically what type of join we're going to do. And then the difference is we use a keyword. And in this case, I'm going to use on. Actually, let's use on. And then we say we want it where c.contact ID is equal to t.contact ID. Notice I'm not going to put a where clause in here at all. And we still get our desired results because the inner join does all the magic for us with this on clause. So we specify where we want to match on, and it does it all for us. Now there's two different ways you can do this, and you'll see this in the homework. You can use the on clause or you can use the using clause. So just so you know, I hardly ever, I don't think I've ever used the using clause in the real world before, because the column names have to match perfectly. So in this case, it works because contact ID, you know, and there's, in most cases in our database, it's going to work. And so you can use this using clause to basically just put the column name in there. You'll find that because you never guarantee that the column names match, and sometimes you just want to do fun stuff, you always use an on clause out in the real world. I always do anyways. So anyways, there's the two different ways. And so I guess just to highlight again, the big difference is ANSI89 matches, it multiplies table A by table B and then filters, where ANSI92 only pulls the matches as they come, as it matches. It filters as it matches, essentially. So it's really nice that way. It's a lot more efficient. And in fact, I don't know if we'll notice it, but see, we got 12 rows in 3 seconds. Let's see how fast this one is. 0.003 seconds. So you can actually see it. This is fun. So I didn't know if there would be enough data here, but it's significant enough that even for our small 12 by 12 model here, you'll notice that we have the same result set using the different standards. This one did it in 0.01 seconds. This one can do it in 0.007 seconds. Now that's going to change just a little bit, like, so there's a 0.002, but you'll find that the outcome is going to be probably better performance. We might have just hit it that one time, but the performance is going to be better with ANSI92. Anyways, does anyone have any questions about this so far? Nope. Okay. So now what we're going to do is we're going to up the ante a little bit. And I'm just going to show you a real quick example. Oh, so someone asked, what does the inner join do? So the inner join is doing exactly what we did before, where we're saying we want to combine records from two different tables. We want to connect them. The inner join, what it does is it tells us that we only want it where the records match. And then we specify what that match is in the on clause. So just like when I ran this one, and let's do this. So let's do, we'll say that one's contacts ID, and we'll call this one telephone. I guess let's not confuse anyone. So this one's coming from the contact table, and this one's coming from the telephone table. So when we normally join, we don't have this filter. We just are like this. So when we connect all of our data, we have all of the records multiplied. Well, when we do our join, we basically say, look, combine those rows, but only where the two values match from the different tables. Because this one's from telephone and this one's from contact. That's how we match whose telephone belongs to who. So it's doing the same thing just behind the scenes, because in this one, I actually can't really show you the difference, right? Because it does the matching prior to me even filtering it out with the where clause. So basically what it's doing is we're taking two tables and we're going to glue them together where they match up on whatever we determine to match up on. So, and there's different ways you can do this. One thing to note, that if, let's say that Brian Smith did not have a telephone number. So real quick, we're going to just simulate that. So let's delete from telephone where contact ID is equal to 1012. Okay, so I just deleted his row. Now, quiz, is Brian's name going to show up in this list? Correct. Yes, he is not going to show up because we only want the ones where the matches are. That's what the inner join does. So let's run this, and we should only get 11 rows now, which we do. Now, because the homework doesn't really talk about a lot of these other ones, I'm going to show you what a left join does. So now I'm going to do a left join. Now we're going to get everybody in the A table, or in this case, contact, whichever one comes first is A, regardless of whether or not they have a telephone. So now let's run this and see what we get. And now you'll notice that we do get Brian Smith, and his telephone number is null because there isn't a match. So if your boss came to you and said, look, I want everyone's telephone number, it's one of those important things to say, well, do you want everybody, even if they don't have a telephone number, or only people that have a telephone number? There's a, pretty big difference. And so if he says, oh, I want everyone, because we're actually getting the list to update people's telephone numbers, we're, to tell them, oh, if your telephone number is inaccurate, please update it. And if someone doesn't have a telephone number, it's probably a good thing to let them know to add one. So that's a good example where we would want to do a left join to find everybody, regardless of whether or not they have a match in the joining table. And furthermore, you can do this one, you can add a where clause to say, oh, I only want people who don't have a telephone number. Let's say your boss says, oh, who's the people that don't have a telephone number? And then you can say, okay, that's super duper easy. We just add this where clause and we say where contact ID is null, right? Because those are the ones that are going to be empty. So boom, there's our Brian Smith. He's the only one in our list who does not have a telephone number. Okay, so now let's keep going here for a minute. I'm going to show you one more, and this time we are going to do a 3-table join, right? And you can join a lot. And in fact, let me see if I've got one here for us real quick. I can show you how crazy these can get in a hurry. Let's see. Okay, just to show you how crazy these can get, this is a query that pulls missing assignments out of our student information system, right? So, we're talking about 2 joins, to get some data. This is one where, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 joins. So we're pulling data from 13 different tables. And what's interesting is sometimes you don't even pull data from that table, but the hierarchy demands that you move through the table to get the data you need, because it's almost like a chain. I kind of like to think of it like a path. Oh, to get to this data, I have to go from here to here to here to here, right? And we don't really have too many examples of that in our database because it's relatively small. But like in this case, if I want to get the term, right, because we only want the term where it's semester 2, right? And that's the name of the term. The term's called S2. So if I only want to get semester 2, to get to that, I have to go, you can see here we have a course, we have a section placement, right? We have a section, and then we have a section placement. The section placement tells us what term that section's in. So then I go to term. And then to get all the way, I have to go through a bunch to get a lot of different stuff. But anyways, that's a good example of how big these things can get and why it's really important to be very efficient in the way we design the database, and then also the way we write our queries. We want to be the most efficient as possible because this is actually very complex. You can see there's a lot of data here. It's got to match on a lot of stuff. They're all interjoins. So it's got to find matches all the way across those. So anyways, let's do a multiple join thing here. So what we're going to do is we are going to get the person's name. We're going to get some rental information, and we're going to get the movie that they rented, So now what I always do when I'm getting ready to do a query, it's always good, you know, because I have a lot of these designs memorized because I've been working with them for a while. But if it's something new, like you guys might be, or you're just not quite familiar, what I always do is, you want to know what table is your data located in. Which to know that, you kind of got to know the design. So step one, know which table the data is located in. The second step is to know what the primary and foreign key combinations are for the table you're trying to get to. So like in this case, if we want to get the person's name and what movie they rented, right? The boss comes and says, hey, I need to know everybody what movies they've rented, right? So we are going to go here. And what I usually do is I usually start out with, you have to have a select list, right? You can't just not have one. So I usually just do select everything. Because really where our query starts is in the from clause. So that's where I like to start. I always like to start with the from clause because I don't really know what I'm going to give my table aliases as or what. So I always start with the from clause. So I usually just do select everything from. And we know that we want people's first name. So I'm going to say contact C, right? And then he says we want everybody's movies they rented. Well, I know that there's this item table. So if I describe item, I can go say, okay, yep, here's what I'm looking for. And a lot of times you can select out of it, you know, like let's do a select everything from item. Okay, yep, this is what I'm looking for because there's the movie name. That's what I want, right? I want the movie name. So then I have to look here and I have to say, okay, well, this is an item. How do I get to item? Because I don't see like a, you know, obviously there's not a contact ID. That wouldn't work at all. So how do I get there? Well, I can look at my list of tables and I can say, okay, what's here? Rental and rental item. Those look promising. So let's do a describe on rental item because, you know, that one sounds promising. So rental item. Oh, boom, there's my item ID, but it doesn't have a contact ID. So how do I connect rental item and contact? Well, let's look at rental. Okay, I don't really have a contact ID in here either, right? I do have this customer ID though. But could customer ID be contact ID? What is it? Well, and sometimes you don't know, right? And so let's go look. So we're going to go into rental and we are going to look at its stuff here. And I'm going to look at its constraints and we'll wait. And let's look here. You know, better yet, let's do this. Let's generate the DDL. Where is it? Oh, we can just look at the SQL here. There we go. Okay, so now we can look here and we can say, okay, we were looking at that customer ID. What is that? And we can look here and say, okay, customer ID is a foreign key and it references contact ID. So boom, there we go, right? That's exactly what we were looking for. And this is one case where the column names don't match, right? And so this is why either A, you got to know the design, and if I was the one designing this, I would have just put contact ID there. But this is there actually for a purpose, and this is exactly why. So this is one of those little design flaws that they put in to kind of teach you why it's good to have good design. So anyways, now we know what it's pointing to, and it's perfect. It's exactly what we want. So now let's go ahead and connect it. So now we know that contact ID can connect to rental. So we're going to call that rental R. And how does it match up? Well, just like we talked about, you know, we had our DDL here. Contact ID is a reference for customer ID. So, and that's exactly how we're going to type it in here. Contact ID, and we want that to be equal to r.customer ID. Now, the nice thing about joins is that you can always test them, right? So I'm going to just run this real quick and see what we get. Okay, boom. I got some rows. Okay, so I always build my joins sequentially and modular so we can go. And that's the other reason why I just do select everything at first, because that way I can run it before I have all my tables. So now let's add our items. Okay, so and just as another quick note, you'll notice that we get 5 rows here. And that's going to grow depending on how many movies they rented, because right now there's just one rent. It looks like almost only 5 of our people rented something, have a rental. So now we're going to do our other join. So as we talked about, we did rental item. And this one was kind of more simple because a rental item has an item ID. An item has an item ID, and we're going to assume safely, because we already are familiar with our database. You never want to assume. If you don't know, check. But in this case, I think we're safe because we built the table that we know that item ID and rental is item ID and item. So we're going to say RI dot. Oh, sorry, I'm getting ahead of myself. We want to connect rental to rental item. So, and we do that based on rental ID. Sorry, I got way ahead of myself there. So we're going to say r.rental ID is equal to ri.rental ID. So let's run this. Okay, so now we're up to more rows, but you'll notice that it's the same 5 people. Okay, but we know our joins are working, right? So let's keep chugging along here. So now we get to the juicy stuff, because now we're joining to item. We're going to call it item I. And we're going to join on that where rental items item ID is equal to I.item ID. Okay, so now when I run this, and I forgot to put on because I said it while I was typing. And there we go. So now we have access to all of our data that we want for our actual thing, because now we have our item title, right? And so now we can just select what we want to show. So in this case, we wanted their first name, their last name, and the movie they rented. Oh, and apparently I got it wrong. So let's see what we did. It's item underscore title. And there we go. So now we have useful data. We can see that Brian Wynn hunted Hunt for the Red October. Oscar did all 3 Star Wars. Smart man. Brian also did RoboCop. And so now we can see, okay, that's kind of was a little messy because I thought he only rented 1. So let's order this data real quick. So we're going to say order by, and we're going to order it by c.contact ID. Okay. Now we could have done it by last name, first name combo. So we could have done c.first name, c.last name. And in fact, let's do it by c.last name and c.first name. So we're going to sort by last first, basically. First by the last name, and then by the first name. So in this case, Doreen Visquel will come before Oscar Visquel because he's got a first name first. Now we can see that Ian did Cars, Megan did Hook. That's another great movie. Doreen Visquel did Camelot. I've never seen I Remember Mama. Oscar is the smart one in the relationship and did all 3 Star Wars. Brian rented the classic Hunt for the Red October and RoboCop. So there you can see that, 3-table join, and it's really just about tracing your way through the tables. How are things connected? And just like if we look up our map on, you know what? And let me real quick show you, because we can actually, if I run the MySQL one, do I have the MySQL one? Well, let's try it. So if I run the MySQL one, the resources I believe are still in here. We can pull up a nice little web to kind of show you what is happening. So let's do that real quick. Okay, so now that we have our MySQL populated, I'm just going to do this so I can show you a little bit about, kind of how you trace your way through this. And if anyone has any questions about that 3-table join while I'm doing this, just let me know. So what I'm going to do is I'm going to create a new diagram. Database, reverse engineer. Okay, so what we end up with here is a nice little diagram of our database, which you can see there's a lot of little connections, a lot of stuff going on. And this is the same model as what we have in our other table. So what I wanted to show you was the query we just did. Okay, so I'm going to move some stuff out of here so that they're not in the way. We got a rental item, we've got item, and we've got rental. So I'm going to show you the chain that we went through here. Where's item? There it is. There it is. Okay, and I'm going to hide some of these just in the meantime. Okay, so this will be enough. So what we did is we took this path because basically we knew where our two ends were, and then we wanted to move between those. So from item, we wanted to go to, well, we wanted to get from contact to item. So we start here at contact, and we went to customer ID. Then we went from rental ID and rental to rental ID and rental item. And then from there, we went from item ID to item ID and item. So you can kind of see how to get to our data, you have to follow this little chain. And we could clean this up quite a bit more. System user really makes things, oh, there we go. That's a quick and easy way. Okay, so if we just want to see the ones we were talking about. There we go. That's way better. So once we eliminate all of our other tables that we're not dealing with, you can see that it's really, there's only one option, which is the option we took, right? Customer ID, rental ID, and item ID. And so you can kind of see how this goes all the way through. And these are really nice diagrams. If you ever want to see this, you can follow along here. The password for root is can get in, just like always. MySQL does a lot better job of these ERD diagrams than Oracle SQL Developer does. That's why I pulled it open here, because these ones are way better. But yeah, these are vital if you're trying to understand a big complex database. These are huge because you can very quickly determine how things are connected, which is very important when we are merging data together for these joins. So anyways, does anyone have any questions so far? Are these joins making sense? Perfect. Okay, so now, because we're actually just about out of time, and I think I've got another lab where I actually do a lot of the last semester recording has a lot of examples, because I actually think I do one example per step in the lab. So I don't think the lab should be any problems. So anyways, I may just end it here. But what you're going to do with the lab is going to be a little different, because he actually just has you pull the ID values. But if you want to, you can add more to them. Like if you want to do more than what's required for the lab, feel free. Or if you need to make certain changes, then you can just add other queries, or just run the queries yourself in the terminal or in SQL Developer. But anyways, if no one else has any questions, then I will let you guys go, and good luck this week. Yeah, thank you guys for coming.